Hey, what's going on? What we're going to be looking at today is not necessarily graphing circular functions, which we've been doing for a long time now, but we're going to look at how you determine what the equation of a trigonometric function is if you're looking at its graph. All right? Very simple concept here, and there are some very simple principles that we're going to use in order to make that happen. So you see here the graph of a sinusoidal curve, as they call it sometimes, and really, whenever you have this kind of curve, turns out that you can write an equation for it that's either a sine or a cosine equation. And so just so you see how each of those work, what we're going to do is we're going to take this graph and the next one over here, and we're going to write both a sine and a cosine function for each of those. All right, now what that's going to mean is we need to determine all of these different variable values that you see in the equation. We're going to need to figure out what would A, B, C, and D equal in order to give you the graph that's right here. And in order to figure out all those values, we need to know what aspects of the graph we need to study and what properties we need to examine in order to find each individual variable. All right, well, let's go ahead and start off with the ones that affect the vertical positioning, because this is kind of undoing what I taught you to do with graph. I always taught you when you're graphing to look at the vertical position first. All right, that's what we're going to do here. And we're doing this in order to find the sine function that goes along with this graph to begin. Now, one of those things that you can learn from looking at the vertical position on the graph is you can learn what the amplitude is, correct? The amplitude being the absolute value of A. And so if we can find the absolute value of A, then we can ultimately determine what A is for our sine or for our cosine function. And there's quite an easy way to figure out what the amplitude of the function is, it turns out. All you've got to do is be able to determine what's the difference between the highest and lowest point on the graph, and then you divide that by 2. Now I'll illustrate that on the diagram in a moment, but for now just write this formula. The amplitude, or the absolute value of A, is always equal to half the difference of the maximum value minus the minimum value. Now, think about what the amplitude tells you. The amplitude tells you how much do the maximum and minimum values vary from kind of the center value or the mid value of the graph. And how are we going to figure out what that mid value is? Well, it would have to be exactly in the middle of the maximum and the min values, right? This would have to be the mid value. And simply the way you'd find the mid value is you would find the average of the max and the min values, or you would add them up and divide by 2. And that corresponds with the vertical shift in the graph, doesn't it? So we can say that the value of D, and we don't have to worry about absolute value here, just D is equal to the sum of the max and the min value divided by 2. All right, in this case, our max is at, let's see, 3, 4, 5, and our min value is at -1. So we would say 5 minus -1 divided by 2, and 5 plus -1 divided by 2, and that would give us our values of A and D. Or at least the absolute value of A so far. Okay, so 5 minus -1 is 6, divided by 2 is 3, so the amplitude is 3. And then the value of D, 5 plus -1 is 4, divided by 2 is 2. Now I'm going to draw that stuff on the graph and illustrate it for you there. Here would be that midline. And then if you look at one of the maximum values, you can see the distance between it and the midline is 3. And if you look at one of the minimum values, such as right here, you can see the distance between it and the midline is also 3. So that means we got the correct midline, or in other words, we got the correct value of D, and we got the correct amplitude because there's an equal amount of space above and below that midline. Great, so now you kind of have a formula to find A and to find D. And by the way, that works no matter whether you're working with a sine function or a cosine function, okay? Next, we want to figure out what the values of B and C are. And B is the next one I'm going to talk about with you. Remember, B helps you find out what the period of the function is. If you do 2 pi divided by the absolute value of b, it gives you the period of the function. Well, I'm going to kind of use that equation to tell you how you find the value of b. Now, if you take that equation and you multiply both sides by the absolute value of b and then divide by the period, it tells you that the absolute value of b is equal to 2 pi divided by the period of the function. So, in other words, if we can figure out what the period of this function is, which is very possible and actually very easy to do from the graph, then we'll be able to calculate what b is. By the way, I put absolute value of b here. That's the most technically right way of writing this equation, although we're never going to work with values of b that are negative. Well, very, very rarely. It's unlikely that you're going to see that. Just in case, know that it's an absolute value there. All right, so 2 pi divided by the period. Let's go ahead and see if we can determine what the period of this function is. Now, when you're looking at a sinusoidal graph like this, and you want to know what the period of the function is, there's a couple of ways to kind of measure that. The easiest ways are to measure peak to peak or trough to trough. Okay, so what's the distance between 2 consecutive maximum values of the graph, or, and it's the same value, what's the distance between 2 consecutive minimum values on the graph? Well, let's take a look at those things. If we go from here all the way over to here, we're going from, look at your intervals, this is pi, then this is pi over 2, and that's pi over 4. We're going from pi over 4. Okay, so we decided every one of these little squares is pi over 4, right? So then this would be 8 pi over 4, 9 pi over 4, right here. And the difference between 9 pi over 4 and pi over 4 is 8 pi over 4, or 2 pi, right? So that tells me that the period is 2 pi. Which means for us here then that the value of b, the absolute value of b, is just going to equal 1, because we're going to do 2 pi divided by 2 pi, and we're going to get 1. Now those 3 values right there are actually going to be the same whether you're writing the sine function or the cosine function. What's going to be different between those two is always going to be the horizontal shift, the value of c that you use. All right? Now we're writing the equation for the sine function right now. And in order for you to do that, you've got to understand what is the pattern for when you're graphing a sine function. And remember, when you're graphing a sine function, you always start with a middle value rather than a maximum or a minimum value. So what I prefer to do is this. I prefer to look at the y-axis and find the nearest medium value, which would be right here. Okay, this one you could use as well, but this one's a little bit closer. And I want to see how far away is that and in which direction. Well, that's at negative pi over 4, right? And what that indicates to me is that this is where my cycle is going to start for the sine function. And then, of course, I'll do the max, mid, min, mid, and finish the cycle right there. All right, but that's where the cycle is going to start. And whatever the x-coordinate is where you're going to plan on starting your cycle, that's going to correspond with the value of c. So c would be negative pi over 4. Now let's put that together into an equation, shall we? All right. Here's the only other thing that we haven't discussed yet that we need to, and that's, if we know the absolute value of a, how do we know whether a is positive or negative? Well, for a sine function, that depends on from the interval from the mid value that you start with is your next direction to go to the maximum, or do you go to a minimum value next? If you go up to a maximum, that means you've got a positive a. If you go down to a minimum, it means you've got a negative a. We're clearly going from our starting value up to a maximum value, so we're going to have a positive value of a, so we'll say a is positive 3. All right, and then we'll write times the sign. And we said b is 1, so we don't really need to write b if it's equal to 1, do we? Times x. Now, if you do minus negative pi over 4, that means plus pi over 4. All right, that should fit what you know. You should know that that means a translation to the left of pi over 4 units, which is exactly what we're saying this graph is. and then we'll go ahead and put our plus d at the end, and our d was equal to 2. All right, so once you're able to find out what the amplitude, the mid value, the period, and the horizontal translation, then we're able to write the equation for that sine function. And we've really done all the work that we can for the cosine function of the same graph as well. Let me go ahead and start writing that in now. One of the things we need to do there is we need to determine, well, where does a cosine function typically begin? And it typically begins at a maximum value, at least if you want a to be positive, but you can begin it at a minimum value as well if you prefer for a to be negative. All right, but I prefer to choose the one again that's closer to the x-axis, so I'm going to choose this maximum value right there. And since I am starting at a maximum value, that does mean that a is going to be positive 3 versus negative 3. So when we write our equation, we'll go and say y is equal to 3 times the cosine. Again, we don't need to write the value of b, but where are we starting here? Well, our maximum value happens to be pi over 4 units to the right, doesn't it? So doesn't that mean we're going to have x minus pi over 4? Because our c would be positive pi over 4 in this case. Plus 2. All right, see how that works? Pretty simple process, isn't it? Hope you thought so anyway. All right, let's take a look at the next graph and see if we can be as successful there as we were here. All right, and we'll begin in the same place here as we did in the previous one. We're going to go ahead and start with finding out what the values of a and d are, because they both are related to one another. They're both the vertical measures, right? So it makes sense to start with those together. And we said you can find the absolute value of a by doing the max minus min divided by 2. Well, the maximum value this graph reaches is negative 1. The minimum value that it reaches is negative 4. So we'll do negative 1 minus negative 4 divided by 2. That'll give us 3/2. Okay, so that's the absolute value of a. And then as far as d, that's going to be the maximum value plus the minimum value divided by 2. So that'll be negative 1 minus negative 4, plus negative 4 divided by 2, and that's going to give us negative 3/2. Actually, that'll give us negative 5/2, won't it? I promise I can add. All right, so negative 5/2. And indeed, I think you can see that we could draw a midline that goes through negative 2.5. Well, let me pause and get that done. There you go. And then you can see that indeed the amplitude is 1.5, which is what that value of a tells us, right? That's 1.5 units right there. And this is 1.5 units right there as well. Okay, so we got the correct values of the absolute value of a as well as d. Now let's go ahead and take a look at the value of b. Remember, the value of b you can figure out by using the period. The absolute value of b is always going to equal 2 pi divided by the period. Well, in this case, the period we can find, let's say, using two minimum values, because we used the two maximum values in the last example. Let's use this minimum value and this minimum value, and we need to know what their x-coordinates are. Now this x-coordinate is really easy to see as being 2 pi, because, well, there it is. But notice then that the intervals here, if the third thing is pi, that this would be 1 pi over 3, and this would be 2 pi over 3 here. So each grid line horizontally is representing pi over 3. So that's how I'm getting negative pi over 3, negative 2 pi over 3 for that x-coordinate. And then what's the difference between 2 pi and negative 2 pi over 3? Well, 6 pi over 3 minus negative 2 pi over 3 is 8 pi over 3. So that's the length of a period here, is 8 pi over 3. And we're simply going to do 2 pi divided by 8 pi over 3, which is the same thing as 2 pi times 3 over 8 pi, just multiplying by the reciprocal. We can do a little bit of canceling there. The pi will cancel out completely from each of them. That will go away, and we can make this just a 1, make that just a 4. So 3/4 is the value of b. Okay, or for the absolute value of b, but we're just going to use the positive version as I said last time. All right, so that's enough to get us started with either the sine or the cosine equation. The only thing we have left to figure out for each of them is what is the horizontal shift, and that will be different for each of them. Let's go ahead and start working then with the sine equation in part 1. And what we're going to do is we're going to find the mid-value that's kind of closest to the y-axis, and it turns out we have a mid-value right on the y-axis, don't we? Which tells me a couple things. All right, what I was looking for originally here is when we have our sine function, would a be positive or negative? And so if this is the mid-value that we're starting at, are we going up first or are we going down first as we go to the right? And we're going up first, so again our a is going to be positive, so we'll use positive 3/2 for the value of a. All right, now the value of b we already figured out is 3/4, so I'll go ahead and plug that in. And then the value of c, well, since we're actually starting on the y-axis, which you normally would, that means we're not translating left or right at all. So our c would be 0 in this case. We'll just have the 3/2 times the sine of 3/4 x, and then minus 5/2 because our d was negative 5/2. Make sense? Then let's do the same kind of thing with a cosine function. And what I want to do is find the either maximum or minimum value that's closest to the y-axis, and it turns out actually this minimum value is closest to the y-axis. Now, if we're going to begin our cosine cycle here, that means we're starting at a minimum value, which means that we're using a negative value of a, so we would use negative 3/2 for a. Still gives it the same amplitude, right? Just means you start the cycle at a minimum value. All right, so negative 3/2 times the cosine of, and our b is still going to be positive 3/4. Our c will not be 0 this time. That point, that minimum value, is 2 pi over 3 units to the left of the y-axis. So that means we're going to put plus 2 pi over 3. The c was negative 2 pi over 3. All right, and then we'll still have minus 5/2. All right, so not that difficult to write a function, or an equation for the graph of a sine or a cosine function, and you can choose which one you want to do unless you're told specifically to do one of those. All right, what I'd like to do is go ahead and show you how you do the same type of thing with a tangent graph. And when you're working with a tangent graph, I think you can still use basically the same process here. Let's look at the vertical things first of all. Of course, we can't use amplitude this time, but we can begin by finding both the values of a and of d again. D is just going to correspond with your central value. There's no formula I can give you because there's no maximum and minimum value this time, but you can kind of look and see where is the point of symmetry for this branch, for instance, and well, right there at y equals 1 would be that point. That's where our mid value is going to be. In fact, let me go ahead and draw that mid value through there. All right, so we can tell here that our d is going to be equal to 1. All right, then the value of a. All right, well, the value of a is simply going to depend on your quarter of the way and your 3/4 of the way through the cycle values, how far they are from the mid value. All right, and it turns out that these are each 2 units from the mid value. So that means our a, the absolute value of a, is going to be 2. All right, again, that's the distance from the 3/4 value and the 1/4 of the way through the cycle value. And we can say then that a is negative because you see how the tangent function is decreasing from left to right, and so that always tells us that a tangent is going to be a negative graph. Now b, I can tell you a specific formula for. Remember that to find the period of a tangent function, we use the formula pi divided by the absolute value of b. So if we do some algebra similar to what we did with the sine and cosine graphs a moment ago, you can find out that the absolute value of b then is equal to pi divided by the period. Now, how you determine the period? The easiest thing to do with a tangent graph is just to look at the equations for the asymptotes, because a complete cycle occurs between two asymptotes, doesn't it? So let's go ahead and look at that then. For our intervals, that's pi, then this is going to be pi over 3, 2 pi over 3, 3 pi over 3. We're going by pi's over 3 again. So this would be negative pi over 3 here. And this would be positive pi right there. And what's the difference between those? Well, it's 4 pi over 3. And if you go ahead and do pi divided by 4 pi over 3, you're going to end up getting 3/4. Turns out, same value of b as we had in the last example, just coincidental, of course. So our b is 3/4. Now finally, to find the value of c, here's what you do. Ordinarily, remember, at the midway point of the cycle, you're centered on the x-axis for your original cycle, because normally we go from negative pi over 2 to positive pi over 2, and the mid-value happens on the y-axis. So what I want to know is how far is the nearest mid-value from the y-axis. All right, now this would be a nearer mid-value to the y-axis, and this one would be over here. So I'm going to use that to determine the horizontal translation, and that is pi over 3 units to the right, isn't it? And so that would be my c. And simply all we have to do now is put this into equation form. The equation for our tangent graph would be y equals a, which we said has to be negative, it's not positive because of the way the graph's going, times the tangent of b, 3/4, times x minus c, so x minus pi over 3, and then plus d, and that d is plus 1. And that, of course, is going to be our equation. All right, thanks. This is what IB is going to ask you to do, quite honestly, more than they're actually going to ask you to graph trig functions, is to write the equation of a trig function. So very important that you've got this skill down. We'll be applying it to some word problem type things in the next section, in the last section of this chapter. Finally made it to that last section. All right, thanks for your attention, guys. As always, keep working hard. See you later.